हेलो गाइस, वेलकम माय चैनल क्वाइट शिक्षा। आज हम थर्मोडायनेमिक्स के कुछ बेसिक टर्म के बारे में डिस्कस करेंगे। स्टेट ऑफ सिस्टम, स्टेट वेरिएबल, स्टेट फंक्शन एंड इट कैरेक्टरिस्टिक, पाथ फंक्शन एंड थर्मोडायनेमिक इक्विलिब्रियम। इसके साथ आपको हैंड रिटन नोट्स भी प्रोवाइड हो जाएंगे। चलो वीडियो को स्टार्ट करते हैं। हेलो गाइस, आज का टॉपिक स्टार्ट करते हैं। स्टेट ऑफ सिस्टम। द स्टेट ऑफ सिस्टम रेफर टू द कंडीशन ऑफ सिस्टम व्हेन इट्स मैक्रोस्कोपिक प्रॉपर्टी हैव डेफिनेट वैल्यू। इट मींस प्रेशर, वॉल्यूम, एंट्रोपी एंड टेम्परेचर मैक्रोस्कोपिक प्रॉपर्टी हैव डेफिनेट वैल्यू। State variable. The macroscopic property required to describe the state of system are called is state variable. For defining the state of system, it is not necessary to define the value of all variables because these variables are interdependents. State variables are two types variable: independent variables and dependent variables. Is definition of independent variables: the variables available for easy change and measurement are conventionally measurement are called is independent variables. Then dependent variable, these variable are can be calculated through relationship with the independent variables are called dependent variables. For example, if out of three variables, pressure, volume, temperature, pressure and temperature are fixed, then value of volume is automatically fixed. For example, लेते हैं ideal gas is a 1 mole of a pure ideal gas. PV is equal to RT. R is gas constant and pressure and temperature को फिक्स कर देते हैं तो वॉल्यूम ऑटोमेटिकली फिक्स हो जाएगा. देन वॉल्यूम इज डिपेंडेंट वेरिएबल and pressure and temperature is independent variable. State function. A state function is a thermodynamic property of the system whose change in value depend only upon the initial and final state of the system and is independent of the path followed by the system. It means the system is depend only initial and final state of the system and does not depend on the path followed by the system. It is known as a state function, or this state function another name is thermodynamic function. For example, internal energy, enthalpy, entropy gives free energy, pressure, temperature, volume and mass. All this property is a state function property. Path function is opposite of a state function. The property of the system whose change the value depend upon the path followed from the process. It does not depend upon the initial and final position is known as a path function. For example, heat, work, etc. Characteristic of state function या thermodynamic function या condition is first condition, the value of state variable या state function is determined exclusive by the state of the system and does not depend on the path or या history by the state of the system is reached. It means state function is always does not depend upon the path function is first condition. Another characteristic of the state function when the state of system is changed, the change in the value of the state function depend on the initial and final state of the system. The finite change in the state function is denoted del या d. Is del v is final minus initial del v2 minus v1 and temperature del t is equal to t final minus t initial is del t t2 minus t1. This is a denote as a final minus initial state is depend on the state function is depend always initial and final state. Another characteristic of state function, if a function e is a state function and its value is determined by two or more other variable x and y, it is possible to have a relation e is equal to x and y. Differentiation dE is curly e upon my curly x is y constant dx plus curly E upon my curly Y is constant X and device. Another characteristic, number 4, the order of two-step differentiation of state function is immaterial. It is means not importance. Curly upon my curly X upon my curly E upon my curly Y is X constant is overall is Y constant is equal to curly Y upon my curly E is upon my curly X. Y constant is overall X constant. This statement is curly square E upon my curly X and curly Y is equal to curly square E upon my curly Y upon curly E is exactly. Last characteristic of a state function is most important characteristic of a state function. This is most important. The differentiation of state function are always exact. It means completely differentiation of a state function. Differentiation of a path function variable are always inexact. It means not completely differentiation. It means is del E is equal to integrate limit 1 से लेके limit 2 तक dE is equal to E2 minus E1. E is a state function. 1 is initial state and 2 is a final state. This means integral must have a definite value independent of a path change. It is most important point. dq q1 into q2 is not equal to q2 minus q1. It means w1 integrate w2 is dw is not equal to w2 minus w1. It means heat and work is a path function. It can be written as a del q and del v. It is not completely differentiation. In exact differentiation. It means overall conclusion of a state function and path function. State function exact differentiable depend on initial and final state, and path function in exact differentiable not completely differentiable depend on path. Thermodynamic equilibrium. When its state variable remain constant throughout, state parameter do not change with time and space. It means state variable या state parameter does not change with time and space. It means known as a thermodynamic equilibrium. Another definition: a system in which the macroscopic property, it means pressure, volume, temperature, entropy in different part of the system do not undergo any change with time, is said to be in state of thermodynamic equilibrium. Macroscopic property does not change with time. This means is a thermodynamic equilibrium. It mainly three type of thermodynamic equilibrium: thermal equilibrium, mechanical equilibrium, and chemical equilibrium. Thermal equilibrium: no heat flow from one part of the system to another part. It means temperature remain constant. Does not heat flow from one part to another part system. Mechanical equilibrium: no mechanical work by one part of the system on other part of the system. It means no mechanical work done is known as a mechanical equilibrium. No movement of matter within the system or between the system and surrounding. It means pressure remain constant. It is known as a mechanical equilibrium. Chemical equilibrium: chemical composition of the system must not change with time. Chemical composition of the system does not change with time. According with time, this is known as a chemical equilibrium. Another point: there is no flow of current of matter. It means no work. It means mechanical property. And no flow of current, it means no heat produced and does not temperature produce. Temperature increase, it means thermal equilibrium within the system or its boundaries. It is condition for thermal या mechanical property. Thank you.